questions?
I have a quick question for you. In terms of on Tuesday, our first day of class, I have a conflict, and so I wasn't able to stay for the entire intro. But I thought I remember hearing you said that you wanted a one-page write-up for each of the 6 modules we did. But then on the slide, I think that was posted, it says like approximately 3 pages for all 6 of the modules. So I was just wondering if you could clarify that requirement.
Basically 3 pages total for the entire course. I think I said a half page per module. Okay. So if you watch 6 hours of lectures in a module and you write 3 lines as what the theme is for each single lecture, that'll make about a half a page.
Got it. Okay,
now
great.
I multiply that by 6 and I get 3 pages total. I mean, I don't care if it's 2 pages or 6 pages. I don't want it to be 50 pages. You know, this is supposed to be something you can just jot down, you know, in you might need to think about it for 2 minutes, but jot down in 30 seconds after the lecture. Okay. And it's to teach yourself to stop every now and then and analyze things. And I'm actually asking you, frankly, for the rest of your life, about 3 or 4 times a day to stop and say, what did I just accomplish? What am I trying to do? And take it back to a soundbite, okay, to help focus your efforts. Half of what I always say, half of what we do, we don't need to do. The problem is knowing which half, okay? What do we throw out? You'll never be able to accomplish all the things that you need to do. And I actually found this was a useful way to do things. I also found when I'm advising students or people kind of mid-career in their 30s or so, I often tell them I had to reinvent myself every 3 years in my career, my professional career. I had to say, what did I accomplish over the last 3 years? Where was I spending my time? What do I have to do over the next few years? And what am I going to get rid of from the past to be able to fit in the new things for the future? And I had, like I said, I had to kind of reinvent, even though I was still a professor. But what you do as an assistant professor has to be different than what you do as an associate without tenure. And that has to be different than associate with tenure. And that's different as full professor. You continually have to renew yourself. And you have to stop and think about these things. It doesn't, if you just go with the flow, you're going to end up in a cesspool. Okay. So anyway, that's that advice. Hopefully that answered your question. I was getting some nods.
Yep.
Okay.
Yep. Thank you.
And that was actually one of the questions that got emailed to me. They wanted a little explanation about these 6 modules. Okay. Well, and be careful, it's not Don Baskin's, to him a module is 2 or 3 lectures, and he's doing a double module on light weighting, which is 12 lectures. But he calls his group of 6 areas, topics that he's going to be covering, he calls those modules too. Well, that's the problem with the English language. We have too many words, but we don't have enough words.
I only did that, like I said, because the number of days that wasn't working out. I kept having to change things around. So by calling it a module, I'm not linked to a single day of lecturing. We can cover another day, though.
I understand. I just want to make sure the students understand your definition of module is different than mine, right, Don?
Right.
I didn't see you. Oh, I see you. I just see the initials there. Okay.
I'm just hiding because I'm multitasking here.
Okay. Someone wanted to know when you submit your 3 pages. That's at the end of the class. It was in my outline. There's a date, and I'll remind you, but it's sometime in the first week of May or something like that, because that's when I figure some of you are going to finish watching 36 lectures, right? When will the student presentation be happening, and how can we sign up for them? I will let you know, but right now, by next Friday, a week from today, you should have picked a topic, and I'm going to be asking you to email me your topic. So I'm going to get 30 or 40 emails over the next week, and I will write back and say, this sounds good, or I will say, no, I think you ought to narrow it down to something like such and such, or I may ask you to give me a call so we can talk, okay? But I want to have some input into your selecting the module so it's doable in 10 minutes and stuff. This giving a presentation is to help you teach some people about something that you're passionate about. And it should hopefully talk something about materials, at least in a broad sense, okay? But I'll let you know more towards April about turning in these things. But just start a Word document and start writing them down. And it's really more for you than it is for me, okay? But I have to have something that grades each one of you individually. That's one of the institute policies. I can't give a whole class a grade. Okay, I have to grade you individually on what you've done. And this is one of the assignments. And it's also one that I think teaches you to do some self-assessment on a daily basis, 3-year basis. You got to kind of look where you are every now and then and say, where am I going? Okay, there was, this next one is more a bunch of questions, individual questions from a student. And,
so I actually have a question.
Yes, go ahead.
I have a few questions. The first one is, if the list of modules you gave us has a specific reference to a module, to a date of a previous year, so basically referencing a YouTube video, does that mean that we can only see it through YouTube, or it will also be done live during the class? For example, your modules are all going to be through video in YouTube, or will you be redoing some of the modules?
I won't be redoing them unless people ask for something. Like today, if we don't fill it up with your questions, I have something on why do I consider steel to be such a preeminent structural material? Okay, that was a question from a student last year. So I basically pulled slides from my previous year's modules that I had and made a little presentation, which actually could go for 2 days, okay, on steel and it's not just steel, it's other materials. Steve was talking about he's working with a company that is working on titanium. And so I'll tell you the economics of titanium and the scale of titanium compared to aluminum or steel or copper. But you can use whatever. You don't even have to just hit the modules. Although the modules, we tried to put things in units of 6, okay? Because that's kind of what the students wanted. That's what EDX wanted and stuff. 6 hours of lectures. If you were to just take the 150 hours of lectures that are out there and just randomly pick 36 of them, not even in a coherent way, I would accept that, because I think that there's actually content to be learned from each hour.
Right. No, but I guess the question is, for example, we know what Professor Lyons is teaching, we know what Don is teaching, but we only, for example, at the last minute knew what Don was going to teach. So is there, if the list of modules just has a reference to a video, should we assume that it won't be done live and we should just watch the video in case it's not done in lecture during the semester? That's kind of
Yes. I mean, there's no way you can cover 10 years worth of lectures in one course, which is why this course can be repeated. You should pick the things you're interested in. One student said she was interested in casting. I did one 7 years ago on casting. She can watch all of those. Another student last year was interested in how we mechanically form and shape things. That's called deformation processing. I have one of those. In these recitations, if you have questions on anything you're watching in any of these old videos, this is the chance to ask me. Okay, because, well, when else are you going to be able to ask me? I frankly put too many hours on there, okay? But it gives the student a lot of flexibility to study what they want.
No, I think that's great.
Okay.
I just want to make sure that since there was no agenda of what was going to be taught this semester live, just to be clear, if I had to just go and watch the videos.
You're right. There's no agenda for me. I'm
Sounds good.
totally growing like an amoeba. Okay. There's no organization. There was an organization each semester. I actually lectured them, but there's no organization for you for topics from me. But you don't even have to take any topics from me. I mean, there's Simone Belmar who did a module, and there's Neil Jenkins, and there's Steve, and there's Don. Okay. So this is actually a pretty flexible course, right? I told you it's flexibility in a stress-free environment.
Hey, Tom?
And one of the students' evaluations basically said they had learned more when they were free to just pursue what they wanted to pursue rather than what they had to learn for the quiz, right? And I think that's true. That's part of, I hate quizzes. When I was an undergraduate, I used to not take courses if they had 3-hour finals. That was a criteria that I used, okay? The only ones I took that had 3-hour finals were the ones I was required to take. And I despise 3-hour finals, okay? I still despise them. Only now I hate them because I have to grade them, okay? Anyway.
Professor Eager?
Yes.
I'm sorry to interrupt. I've got a question. I'm getting a bunch of emails here from Zoom saying that all these people have joined my lecture and it has the Zoom number associated with my lecture. But some of those people like Andrew and Shreya, you guys are on this meeting, which has a different Zoom number.
Right. I don't know what happened, but I sent around a link for this Zoom meeting.
I think the email link was incorrect, but I got an Outlook notification or an event reminder, and that had this link. So that's what I used to join. Because when I joined that meeting, I said I was the only one in it.
Yeah. Okay. Well, I'm recording this one, so if they want, they can watch it. And it's really for questions. So I don't know. I don't want to take the time from all of you to go off and, if someone misses a recitation, what's the big deal? You're not going to be quizzed on it, right? And if you really want it, you can watch it later. And by the way, the introductory lecture is on my website now. And I'm hoping, I don't know if Don's is up there yet. And Steve will figure out what's going on with yours. But hopefully we'll all be videotaped. Other questions? This is good.
I had another.
Yeah.
So there's 3 courses that I'm guessing overlap. So there's material processing in practice, and deformation material processing. So I'm wondering if you could
tell you the difference.
I guess let me know what is in each so I can decide which one I want from all of those.
If you go to the website, it actually gives you a little synopsis, a very brief synopsis of what's in each. But
okay,
I believe on deformation processing is Tom Eager teaching out of Al Backhoffen was the professor who taught me as a sophomore, and he was a world's expert in how do you shape and form metals, okay? Whether it's forging or drawing or extrusion or wire drawing, how do you stamp car bodies, okay? And I used to teach his course 40 years ago. And then I taught it once as a module. And actually, it's one of my favorite modules because I'm interested in the topic, but it's everything that goes through the crystal structure, what we call the anisotropy, that allows you to do deeper draws of steel and aluminum to greater depths, like a beverage can is a very deep draw. It's actually called drawing and ironing, but it's a little bit different. But it goes through all those solid metal forming processes, okay? From the crystal structure through the forces involved in drawing, forging, wire drawing, any way you can think of, coining. How do you stamp a coin and what forces are going to be involved? The other materials processing ones are probably ones that were done by Simone Belmar. And he basically gives a lot of examples from some of his consulting experience of how processing in general is important. He's more of a mechanical engineer in doing this. And so it's a more general approach like you get in a mechanical engineering course, frankly. Mine are more in depth, okay, into the materials aspects. For example, his process is not going to get into the crystal structure and how it changes things. That's kind of a secondary effect, a very important secondary effect. Don Baskin will tell you that was critical in all the forming of automobile body sheets, okay? It has been critical for 60 years. But that generally a mechanical engineer won't worry about that. In fact, I think yesterday Don was talking about, looking things up in a table, okay? And I used to, when I was lecturing live, I would bring in a piece of an aluminum bar, okay? And I would say, what's this? And I'd ask the students, and some students say, well, it's metal. Well, that's correct. Another student would say, well, it looks like it's aluminum, and that's correct. And if I was a metallurgist, I would say it's 6061T6 aluminum, okay, which is a specific alloy and a specific heat treatment. It turns out every engineering group has its own phraseology or semantics or whatever you want to call it, okay? Civil engineers use S for stress. Mechanical engineers and materials engineers use sigma for stress. And so if you go to a civil engineering book, you've got to kind of learn the notation because everybody uses things that are different. I used to call this learning to be multilingual. If I'm talking to an audience of a bunch of managers, okay, I have to talk managese, okay, which is kind of Sloan School technology. And they would be happy with it's a bar of aluminum. But if I'm talking to a bunch of metallurgists, I better tell them it's 6061T6 because they're going to know the difference and they're going to be concerned about the difference. And if I don't answer that question for them, their mind's going to be wondering about that and not paying attention to the rest of what I'm talking about. You have to speak to your audience, okay? And so you can't give the same lecture to everybody, although that's what I'm forced to do in teaching, which is one of the reasons I teach in parables by telling you stories, okay? So I'll tell you a story about consulting, okay? Since you brought it up. Students would ask me about how do you consult for a company, and I would point out that, well, one of the problems in consulting with a company is management called you in as a consultant because they had their own engineers who've been looking at this problem for several weeks and can't solve it. So they're going to call some place like MIT and find somebody who supposedly knows something. They're going to bring them down, pay them hundreds of dollars an hour. And the engineers who are making $75 an hour or whatever are not really all that happy about having someone come in. And the worst thing that expert can do is walk in and shoot from the cuff and give the answer in the first 5 minutes, okay? So what happens is you go into a meeting when you get there as a consultant, and you got the managers who want the problem solved, but they don't really know what the problem is. That's why they brought you in, and their engineers can't explain it to them. They just start talking engineering to them, and it's like two people talking different foreign languages, okay? And so the managers will introduce you to the engineers, and the engineers will explain the problem, but they don't want to really explain everything, because if they think you're going to solve it quickly, it's going to make them look bad. Okay. So you listen to all this, And then you ask, well, can we go out in the plant and take a tour? And they'll all say, yeah. They're all ready for a break. Okay, got to get a new cup of coffee or whatever. You go out in the plant and you're walking around and you find the foreman, okay, the hourly worker, and you find a chance to talk to that guy. And at first you have to establish a little rapport with him about this pretty interesting machine you're working with here. And you ask him what the problem, him or her, what the problem is. And they will tell you. They know what the problem is. The answer is right there in that company. Okay? But the managers and the engineers don't respect the hourly worker who's been doing this for 40 years and knows exactly what the problem is and has tried to tell them and has gotten to the point where he refuses to tell them anything else. Okay? This is all a communications problem. So he tells you what it is. He tells you in his jargon, his language. You go back into the conference room, you translate it into managese and engineeringese for everyone else. You walk out, you know, having solved the problem. You didn't solve the problem. You didn't know what the problem was. All you did was help them, and they still don't even understand it afterwards, even if you tell them the story. They don't understand the answer was right there in their own factory. And they just didn't have the respect for each other to ask each other. And they didn't try to speak each other's language. Okay? It's mostly communications problems, folks. It's not technical problems. So I could tell you another story, but you have other questions? Okay. I will tell you the other story. Have I told you the donuts story from Honeywell? So for those of you that might be LGO students, this is in the early days of leadership manufacturing, okay? LGO used to be LFM. And Honeywell became part of the program. And there was Honeywell had bought this little $50 million business down in New Jersey. And one of the students had to go do their internship down there. And I was the advisor. So we went down together to visit the site in the spring before she started in the summer. And this little factory had been run by it was literally a mom and pop. A husband and wife had started making plastic sheets, different colors, different textures, different thicknesses. You needed enough sheet to cover 3 football fields with this texture, this color, and this thickness. They would make it for you, okay? And they had all kinds of quality problems, okay? They had a workforce that would steal each other's tools, okay? They had to lock their toolboxes from each other because they would steal each other's tools. Management would not talk to the hourly workers. They wouldn't tell each other. They hated each other. It was a unionized shop. And anyway, they just couldn't get along. In fact, there's the story that I call it the mad shitter. Okay. And they told us this story. There were some people that hated management so much when they would go to the restroom, they would take their excrement and paint the walls with it. I'm sure they took some plastic gloves or something with them and leave the carrel with, you know, this mess on the walls. And they never could find this person, but they called him the mad shitter. Okay. And so this student who was going to be going down there and spending her summer there, she was just sort of, you know, she couldn't believe what she was walking into, right? So we listened to all this and I said, let's stop at the diner on the way back to Newark Airport and you can get a cup of coffee, I'll get some orange juice and let's talk about this, because I didn't want to talk there at the site. So we go back, I said, well, what are you going to do about this environment that you're going into? I mean, how are you going to solve their quality problems and stuff? She says, I don't know. I said, well, I know, and I will fund this. Every Friday, you're going to go and buy a box of donuts. Have I told you the donut story before? Anyway, I think Steve started it anyway, but
Yeah.
Okay, but the
It works.
you're going to buy a box of donuts and you're going to put it at the coffee desk for the hourly workers. And you're not going to, you put it up there when not necessarily, I don't care if someone sees it, but they're going to figure out that you brought them donuts. And then you're going to go out later that morning and you're going to ask them if there's anything you can do, or ask them what the problems are. And if you can do it, if there's anything they think you might be able to do to help things around there. So you just gave a peace offering of a few donuts and you're asking for things. I said, you're going to take those things and you're going to take the low hanging fruit that you can solve. And some of them are going to be impossible things, ignore them. Just solve one or two. Make a difference that next week in their environment. And within a week, the foreman's going around, putting his arm around her, showing her how the machine works, explaining everything to her, telling, if we had this, we could make better quality here. And she would go back and she would translate it for the management. And she would get them to do the investment they needed to do to improve the thing that the foreman had been telling them for 6 months, but got tired of telling them. There's an important principle here. I always say, I don't know anyone who goes home at the end of the day saying, I did a really lousy job today and I'm proud of it, okay? People go home and they say, I tried to do a good job today, but I couldn't do a good job because of these impediments, which might be some manager that won't listen, some manager who yells at them whenever they make a suggestion, some manager who shoots the messenger, whatever. If you can get around those things, you'd be surprised at what you can do. And if they used to call it empowerment, if you actually listen to other people's suggestions and listen respectfully and listen with translating ears, they may not be able to articulate it. They didn't go to college necessarily. But if you show them respect, they will show you respect. She was able to have a very, very successful internship just for a box of donuts every week. And Steve, you want to say you've seen the donut effect?
Yeah, I have. Well, sure. Absolutely.
It works. Go ahead.
I'll say also add that the UAW also accepts donuts. It's a formidable lubricant for the United Auto Workers as well. I have personal experience with that.
Okay, so simple little things that has nothing to do with technology. This is a structural materials course. Yes, it is a structural materials course. And in those video archive modules, there's lots of information, more than you could absorb in one course. But being successful has a lot more to do with donuts and respecting others than all the technology and all the differential equations in the world. Frankly, if you need a differential equation solved, hire an MIT grad. They can do it, okay? You don't really need to learn how to solve a differential equation. Well, actually you do. If you want to graduate from MIT, you've got to learn to solve differential equations, okay? Because you won't pass the quizzes. But if every course was like mine, you wouldn't need to solve a differential equation, okay? And Don, how many differential equations have you personally solved in your career?
Not a lot. There certainly have been some times where I was working in sort of more of a research environment where that skill was useful. But as a sort of a practicing engineer releasing real parts, I don't think you'll ever use a differential equation.
Well, I've only done it 2 or 3 times in my career.
That's really interesting. I mean, I must have spent 6 months in school learning about differential equation.
Right. And it's an important skill, and it teaches you a thought process the methodology you learn by learning about differential equations and how they work, is very important. But actually being able to solve a fourth order differential equation, who cares? There are people that can be hired at a much lower rate than your salary that are happy to do it. And things like the finite element analysis. I learned finite element analysis when I worked at Bethlehem Steel. They put me in a course. It was mid 70s. It was sort of a new technology then. I was all excited. I was going to go and solve this spot welding problem using the finite element analysis. And I went to my boss and I said, I want to do this project. He says, well, no, we don't think that's worthwhile. This is in the research department of the second largest steel company in the world. Okay. And I said, well, I'll do it on my own time, because I was interested kind of from an academic point of view. No, I said, well, I'll do it on Saturdays. Okay. No, I said, all I need is an account number to use the mainframe computer. We didn't have personal computers in the 70s, right? And nope, they wouldn't allow me to do it. Okay. Well, a couple of years later, I left Bethlehem Steel, or a year later, I left Bethlehem Steel, because I realized they were never going to let me do anything until I had paid the price of being there for 30 years and had an attitude lobotomy like all the other managers. Okay. They weren't going to allow me to do things. What really irritated me is the exact same problem was solved on the same finite element analysis. And the paper was published in the Welding Journal 2 years later by a guy from General Electric Research named Art Need, and he won an award for his work. Okay. And I thought, okay, I had the idea. I wanted to do it. I could have had this done. But I had managers who didn't see the value in it. Okay. Well, this is supposed to be research, folks. If I saw the value in it and I knew how to do it, I wouldn't need to do it. Okay. But that was part of the problem. The culture at Bethlehem Steel is they wanted to clone you into their type of person. They didn't want any type, and I'm not talking ethnic or racial diversity. They didn't want any diversity of thinking. They wanted everyone to think the same. And I don't know that I'm seeing any Japanese names right now, but I spent a year in Japan, and one of the strengths of Japan is they have very fixed ways of doing things, but the Japanese have criticized themselves for not being creative thinkers. Well, some Japanese are creative thinkers, but real creativity comes from going in another direction than everybody else. Okay? When everyone else is heading in one direction, you go in the opposite direction. And actually, to tell that story, I learned that when I was 7 years old at an Easter egg hunt. And if you've ever been to a soccer game or an Easter egg hunt, in a soccer game, all the 8-year-olds run towards the ball. Okay, they don't realize that if the soccer ball gets kicked away, they all have to run in the opposite direction, right? And so the person that could win when they're 8 years old with soccer is the one who stays behind and waits for the ball to come out. And I learned, someone said, I found an Easter egg, and everybody goes running over because they figure all the other Easter eggs are right there where they found that one. And I remember starting to run over there, and I could see the backs of all these heads. And I realized there were another 20 eyes in those 10 kids looking in the same place. And I thought, even as a 7-year-old, I'm going to look over here because I'll be the only set of eyes looking over here. Okay. And so I started looking where other people were not looking. And frankly, that was the source of my professional career. I would look at the field. In my field, it was welding. And people were telling me, oh, go do this, because the big name in welding, all of he and his students were looking at welding metallurgy problems. And I said, no, I'm not going to be another set of eyes looking at the same problems. Those are all bright people. I had respect for their abilities. I wanted to look where no one else was looking. And as I sometimes liken it to a farmer plowing a field. If you're plowing the same field that has been plowed for 100 years, it's unlikely that your plow is going to turn over some gemstone. But if you're plowing a brand new field that no one's ever plowed before, it's possible that you might uncover a gemstone. So it's best to look where other people are not looking and use a little creativity to ask questions that no one's ever asked before. And that, if you want to know a success for being an academic, if you ask enough questions that no one's ever asked before, every now and then one of them will work. And you'll become famous for answering a question that no one ever asked before. And that's sort of the secret of being an academic, in my opinion. That and having a lot of money. Research money makes, and being at MIT where you have bright graduate students that you can hire and let them do the thinking. That's even better. Other questions? If not, I'll share a couple of things with you.
No, I just want to resonate. I feel resonate when Professor talk about like creativity is like a lot of people do like one direction, you do the opposite. Because I can totally feel that because when I studied at school, I was majoring in industrial design. And then at that moment, there's a big trend on like UX, UI. People all works on interface, you know, like a screen design, web design. And then most of my classmates, they go that direction because the industry needs that kind of designer. And then, but the truth is like, as a people, as a human, we still need the physical stuff. So I'm passionate about object and product design. So that's why I feel like, yeah, when most people do certain direction, try to do the opposite because you can show your value and creativity from different perspectives.
Yep. And that's really what creativity is about. Is they call things creative because it's something someone hasn't done before, right? And if you're following the crowd, whether it's nanotechnology, additive manufacturing, high strength ceramics, okay? I mean, I can go through a list. High temperature superconductors, okay? Everybody's going in the same direction. And that's when you need to stop, reevaluate, do your every 3-year evaluation or your weekly evaluation and say, do I want to be just part of the crowd? Or do I want to go and blaze a new path? And, you know, 9 times out of 10, that new path may be fruitless. But every now and then you find a new path that's fruitful. And then people say, oh, that's the such and such effect. And they use your last name to describe it. Okay. Other thoughts?
Just to echo Professor Eager's point here, I can tell you that in the mid 2000s, working at Mercedes in Germany, they were terrified of Lexus. They used to sit around and talk about how scared they were of Lexus to eating their lunch. And they kept focusing on how are they going to beat Lexus? How are they going to beat Lexus? At the same time, Elon Musk was going a totally different direction in electric cars. Guess who ended up eating Mercedes lunch? Tesla. So talk about the success of going a different direction. There's a great example for you.
Yep. There's lots of examples if you look for them. So this has become more of not a structural materials recitation, which is fine. I'm more interested in giving you some thoughts from our experience, if you're willing to listen to a bunch of old people talk about their experience. But that actually is a little bit of respect. Do you have some respect for people who have already made the mistakes that you're going to make? Okay. And understanding that if you go out there into a factory, you don't have to solve the technical problems. The first thing you have to solve are the people problems, the communication problems. Other questions? if not, let me just talk about one handout that I gave that you've got. We're not going to spend time on it, but yeah, okay. So you now should be seeing a screen that's got the Boston gas tanks. And this basically shows you that the blue stripe is actually got the silhouette of Ho Chi Minh. The woman who developed these, painted these Boston gas tanks. Was
I think we're looking at your email here.
Oh, okay. I hit the wrong screen share. Here we go. Okay, now you see Ho Chi Minh in blue, the silhouette of Ho Chi Minh.
Sure do, yes.
Okay. So if you drive south on the Southeast Expressway and look at the Boston gas tanks, you'll see the silhouette of Ho Chi Minh. It was more pronounced in the more royal blue. When they repainted it and changed the tanks, they fuzzed it up a little bit. That's one thing that you might want to learn about Boston. Another one that is actually closed because of COVID is the glass flowers at Harvard University, the most interesting museum in Boston by far. Nothing else like it in the world. And there's some other things here. If you have a chance and we get rid of all the restrictions from COVID, you should take a chance. Boston is a great place to learn about different things. Okay, so if you're not from Boston, you ought to learn some things about the Boston area. And so that's a little list of some of those things. Another thing I gave you, which actually is let's see if this should be, you should now be seeing what's a paper. I gave you the paper. It's called Materials Research Needs for the 21st Century. This is a National Academies Press Committee. This is Appendix C, which I wrote. And this Appendix C is my structural materials course as of about 2004 or 2005, condensed to 4 pages. So the question you asked in the beginning, which of my courses would be the best ones to look at? Well, here's 4 pages that basically give you the Cliff's Notes version of 12 lectures on structural materials. My approach, and that's part of what I was going to discuss today, some of these things. One of these is this little plot that I'm putting up right now. This is pounds per year of a material versus dollars per pound selling price on a very, very large scale log plot. And over here you have diamond, which is very expensive, but they only produce 10,000 pounds. This was back in it's actually from a 1962 internal General Electric report done by a guy named Jack Westbrook, who's a graduate of MIT Materials. Jack just passed away a couple of years ago, but on this plot, you can see that the most widely used material is stone, and then cement and steel, okay? They don't have wood, well, they do have wood. The 4 largest usage of materials, the highest volume, are stone, cement, wood, and steel. These 4 are I call the billion ton per year club, because if I go back to these today, and I have it in that outline that I gave you a link to my slides. I redid this in 2014 and the plot looks almost the same. The most widely used material is crushed stone, 50 billion tons a year. You might not think of it as a structural material, but it is. That's the structural material they put down underneath every railroad track, okay? For every pound of steel track, they probably put 100 pounds of crushed stone. Why? Look, I've got a heated driveway. It's great on a day like this. It's snowing out. I don't have to do any snow shoveling. Okay. It's all melted when I get up. But underneath that, there's about 2 feet of crushed stone. Because when you melt the snow, the water's got to go somewhere. I don't have any flooding problems because of crushed stone. And then there's engineered wood product, or actually the next one is engineered wood product. You know that as plywood, but it's not just plywood. If you were a building contractor over the last 25 years, we don't use 2x6s most of the time anymore. We actually make composites out of wood that are actually beams that are lighter than a solid 2x6. Okay, we make a flange out of solid wood and a top flange and bottom flange out of a small piece of 1 inch by 2 inch wood. And then we put a piece of plywood particle board in between, and the whole thing is lighter than a real 2x4. It's easier to make. You don't have to wait 20 years to grow the tree. You can actually get the wood for this in 5 years of growing the tree. So there are advantages to engineered wood products. I have a beam in the top of my house. My house is 80 years old, but to put in solar cells on the roof, they maybe reinforce the structure. They took a new beam that was engineered wood product. It was about 6 inches by 24 inch cross section by 40 feet long. And they brought in a crane and lifted this thing into the top beam of my house. Okay. Now, where would you get a piece of wood like that today? They used to build things like the USS Constitution out of that, but we don't have trees like that in the world anymore. Well, we can engineer it, and it's actually a stronger beam than if it was a solid tree trunk that might have knot holes and other things in it. So engineered wood products is 3.5 billion tons a year. And the next at 2.2 billion is concrete. Concrete has passed steel as it's for the number 3 spot. And that's because concrete is cheap. The problem with concrete is the same problem with crushed stone is transportation cost. You can't afford to transport this stuff very far in most cases, unless you're doing it by ship. And you can't get everywhere in the world by ship. But concrete is widely used in the third world for building buildings because it's inexpensive. It holds up in all kinds of weather. The Romans built roads out of concrete and they're still useful. Okay. But last is steel. And after steel, you drop down to aluminum at 45 million tons. Well, 45 million is a lot less than 1.5 billion in steel. 95% of all metal made in the world is steel. 95%. Why? I could show you plots, but steel has 10 times the strength and toughness of stone, engineered wood, or concrete. It's 10 times stronger. And as Don said yesterday, iron is cheap. It's very cheap.
Cheaper than potting soil at Home Depot. Check it out.
Right. Okay. It is cheaper. Well, it's just like bottled water is more expensive than gasoline now. But in any case, but yes, steel is cheaper than potting soil. I hadn't thought of that analogy before. It's cheap, it's tough, and it's strong. And compared to the other 3 in the billion ton per year club, it's 10 times better. That's why I was saying 30 years ago that we wouldn't have all aluminum cars for 25 years. And that's true. We didn't have them for 25 years. But 4 or 5 years ago, whenever we got the F-150, we now have some all aluminum cars. in high volume.
The primary structure in the F-150 is not aluminum, it's steel.
Yep. Okay.
The ladder frame is steel.
Yep. So there's still a lot of steel even in the F-150, and you wouldn't want to be in a wreck if you didn't have steel in a car. Okay. It still will have a lot of steel, and Don will go through that. He's going to give you the figures of merit on when I said, you know, you'll get things at different levels. Don goes about 3 or 4 levels deeper than I go in structural materials. Okay. He gets into a lot of the fine details that you need to know to make a competitive product. I give you the broad brush academic approach, which was one of the questions earlier. Okay. Okay. Well, that's enough for today. If you, I think I may schedule one for Monday because I didn't show you the whole steel thing, and there were a fair number of questions, and maybe we had some other people who didn't make it, but that's enough for today. I appreciate your attending, and I appreciate the questions. Thanks. We'll see you next week.
See you next
But
week, everybody.
Okay, you don't have to come, folks, but I'm not going to hold it if you don't. Okay,
Have a good weekend.
thanks.